Or to come with the proof party. Right now, we need to learn a little bit about how to do a proof. I think you're ready for this, and I'm excited to show you. I'm going to carefully do 4 problems today, just to kind of let you know it's going to be a little bit more of me just showing you. I'm going to ask you to do some problems for homework, but more like during this class period, I'm just going to show you, okay, because each of these 4 problems has a little bit of a different theme. Okay, and our first theme is going to be what I would consider like a basic, just using basic identities. To be honest, this would be a problem that maybe you would have seen on the mini check that you just took. I think that you're going to say that the steps that I show you for cosecant squared over cotangent to prove that it equals cosecant times secant, the steps that we're going to walk through here are a little bit more basic. Now, again, do you see kind of my presentation to you here? I'm telling you that this equals cosecant times secant. Your goal is to prove it. Okay, now, a couple things, especially if you've never done a proof before, it's fine. It has a 2-column format. Basically, with a vertical line, we can create the 2 columns. And the left-hand column will show the math, and the right-hand column will show or give a reason. There's always has to be like a reason for your steps. The other thing that we want to be careful about is that we understand that we're trying to prove that this equal sign is legit. What does that mean? That means that you're not allowed to move things side to side. Okay, a very common mistake is when I see students do something to both sides. Okay, like multiply both sides by cotangent. Don't do that. I'm trying to show you that that's not actually legal. It's not legal because we're trying to prove that this is equal. So basically, we have to start on one side and make it look like the other side. Okay, and I'll help you work that out. We just want to be careful that we don't take that temptation. All right, so this is supposed to be good news. How do we do this? Okay, well, for this particular problem, I just want you to notice something. I want you to notice that the side that we're trying to show, the side that we're trying to get to, it already is seen in part of our given. In other words, I'm already given half of my proof, okay, because cosecant squared is already at least a cosecant. And so if we just kind of take a deep breath here and split up this cosecant squared, now this is our first step, and a lot of times that first step is the most important, but I just want you to see that if I split up a cosecant squared into a cosecant times cosecant, I already have half of my proof accomplished. Okay, I already have a cosecant. And I guess what I'm saying here is I don't want to mess with that anymore. I'm going to leave that yellow one alone. Let's give a little reason over here. Now, the reasons can vary, as you guys will find out, so don't try to figure it all out in one problem. But what I did right here was really some algebra. And the algebra that it was interpreting an exponent. If I write the word exponent here, that would be sufficient. But I want you to realize that when I write the word exponent, what I mean is that I interpreted the exponent. You might say that I applied the exponent. I actually kind of did the exponent backwards. But I think the word exponent is detailed enough to describe what happened by splitting this up. How about something that you've seen now more than once or twice? How about taking a reciprocal and flipping it up? Now, the reason that this is a good idea is because when I look over here, there are no fractions. So I'm pretty sure that I don't want this denominator because there's no denominators over here. So we're going to flip up cotangent, again, because we don't see any fractions in our final answer. Now, when you flip cotangent up, it turns into a tangent. And purposely, I've shown you that many times because it's a really popular method, and you guys did a nice job with that on the mini check. Guess what reason we're going to write down over here? It's got to be a little more specific than just flip. What I really did was I used an identity. Now, when you use an identity, you must state the identity. The identity that I used was the reciprocal identity. And I want you to look real carefully here how I am being specific. I'm going to expect you guys, once you catch on to this, to do the same thing. So cotangent flipped up to become tangent, but that's because it's a reciprocal identity. Now listen, we want to be careful that we don't do too much magic. Magic would be like somebody looking at this blue pair of functions and abracadabra saying that it's going to equal secant. It's going to, but we're trying to prove it. So what I'm saying is that we need at least one more step. I can't just say cosecant tangent equals secant. A little bit too much magic. So show it. Now, how do you show it? You've been around this. Again, I don't know if we did this exact problem one day, but I know on the mini check you saw a problem that was like it, because each of these guys can turn into a sine and cosine, like turning cosecant into 1 over sine and turning tangent into sine over cosine. Now, this is also a very popular strategy. What did I do? I turned everything into a sine and cosine. And you guys have been doing a nice job with this also as we've been going through the last couple days. Now that it's a proof, you have to give a reason. Now, I actually did 2 different things here. The 1 over sine, that came from another reciprocal identity. Again, cosecant turning into 1 over sine is a reciprocal. Tangent turning into sine over cosine, okay, we've done that a lot, but you realize that that's a quotient identity. In fact, it is the quotient identity. So tangent turning into sine over cosine has to be specifically written as quotient. So both of these are identities. And honestly, folks, this is like the main way that this lesson is different, that I'm given a reason for my steps. Honestly, it's the main way that this is different. I'm given a reason. I'm still doing the same math, like canceling out these signs. Now, when you cancel out those signs, you're left with 1 over cosine. But again, I got to give a little reason. In fact, what I just said verbally would be fine. If you're like, can I say cancel? Sure, you can say cancel. I've seen students say divide. Sometimes you do algebra, and the algebra could be written with different words. So when I divide those signs, when I cancel those signs, I'm left with 1 over cosine. And do you realize that that's exactly where I want to be? Because 1 over cosine is secant. 1 over cosine is secant. Of course, I just need to show it, and then I need to say it. So I turned 1 over cosine into secant, and that's one more reciprocal identity. A lot of reciprocal identities to go through this little proof. Okay, now, again, continue to have a good attitude. Continue to have kind of that I can do this approach. And if you're looking at this and saying, I don't know if I could have done that, I mean, that might be true, but by the time I ask you to do this for a grade, you will have seen a couple. I will have given you some hints. I'm trying to make this so that it's all possible. As long as you try, as long as you want to make it possible, I think you can do it. Okay, so proof number one, basic. Basic doesn't mean easy. Nothing is easy right now. But it does mean that we applied some basic identities. Let's use some algebra. Every problem uses algebra, but you'll see this problem, it sort of has algebra written all over it. Secant plus 1, that quantity, times secant minus 1. So we have two quantities multiplied together. And I want you to prove, well, we'll prove together how that equals tangent squared. Sometimes students will ask, how do I know what side to start on? Well, it doesn't have to be the left side all the time. Although we tend to look on the left, it's not necessarily that you have to start on the left. You just want to start on the side that seems to have something you can do, something you can change, something you can actually, in this case, something you can FOIL. So when you look at the left side, there's something we can do. And this would be the algebra. Take that algebra baton and run with it. Do the FOIL method. You actually have done a FOIL problem like this. You didn't do it on the mini check, but you have done something like this. You get secant squared from the first distribute. You get a minus secant and a plus secant. Some students will not show that, and that's fine. You don't have to show it because it's going to cancel out. And then you end up with a minus 1. So we do 4 distributes, and we end up with this grouping. Like I said, the secants in the middle cancel out, and you're left with secant squared minus 1. I wouldn't require you to. Now, I'm going to do it up here because I showed it. So I would write like FOIL, and then I would add something like add or cancel. But again, if you combine this into one step and you just write FOIL, and you get one step and you get down to this, that's fine. Secant squared minus 1. I'm not saying you have to have this memorized, but you should be feeling like you've seen that before, or at least that if you look in your book, that you've seen it before. So if you look in your little book, secant squared minus 1, well, you get the jackpot, okay? Right away, it's equal to tangent squared. Not every proof has to have 1,000 steps. Okay, basically, this is about a 1 to 2 step proof. But you have to give a reason. To say that secant squared minus 1 is equal to tangent squared was a Pythagorean identity. Now listen, you want to be specific. So don't just say identity. Say Pythagorean identity. Algebra. Now, there's other types of algebra that you might be asked to do. Really, every problem we do has some type of algebra. Honestly, this problem also uses algebra, but it's going to be specifically a common denominator. Common denominators kind of take us to the hardest type of problem I'm going to ask you to do. I haven't asked you to do a common denominator yet for a grade. Okay, on the mini check, there really were no common denominators, but they're coming. So I want you to be able to do it. I have shown you some of these. Once you catch on to a common denominator problem, you at least we hope that you realize that it really is the same method every time. It just might produce some different result. So let's try to understand the method. I've got tangent plus cosine over 1 plus sine, and it equals secant. Maybe you remember me saying before that when you're adding fractions, you need a common denominator. The first thing to realize in this problem is that I'm adding fractions. What I mean by that is you want to look at tangent and say that that's really sine over cosine. It's really a fraction. Now, if you're able to do that, you're growing. And remember, that's what we're trying to do in this chapter. So to look at tangent and say that's a fraction shows growth, but to also look at this and realize that I'm adding fractions. And of course, when we're adding fractions, we need a common denominator. What reason am I going to give here? I got to say something. How did tangent turn into sine over cosine? Starts with a Q, okay? Yeah, you got to say it. By the way, when you finally do these for a grade, you can go back and fill in the steps. I don't really care if you do the proof, then write the steps. You'll figure out your own method. I just want to make sure that we don't forget it up here on the board. All right, are you ready? Common denominators. These really don't have to be like awful. You just have to be willing to look at this denominator of cosine and say that it's missing this denominator. So to make it common, I need a 1 plus sign. I need to give it what it's missing. So I put a 1 plus sign there. You also have to put 1 plus sign in the numerator. But the way that this goes is you basically always put what's missing into that other denominator. This one over here is missing. Well, it's missing this cosine. Give it what it needs. Give it a cosine. Make sure you put cosine in the numerator also, because that's the way you make a common denominator. Now, you've heard me say this before, at least I know I've said it before. I don't know if you've heard it, but sometimes it gets a little worse before it gets better. Like sometimes you end up having to create a little bit more before I can make it simplify to be less. Sorry, Mason, I didn't want to ignore you. So we're going to do the distributive property. We're going to kind of make this get a little bigger. Okay, be willing to do it. Sine times 1, it's sine. Sine times sine is sine squared. And then over here, cosine times cosine is cosine squared. Now, I've also taken the liberty of adding everything together. I don't want you to get confused here. There were 2 fractions, and I've already added the numerators because I don't feel like writing down the denominator twice. I figured you probably don't either. So we add the fractions and have a common denominator. Now you might notice I didn't distribute the denominator. That's a little bit of some wisdom. Now I'm not going to distribute cosine into the denominator because many times that denominator is there to cancel, but I'm not going to be able to cancel it correctly if I distribute this. So just kind of trust me, and I'll show you what happens. But we need to give a reason over here. I actually did 2 things. I made a common denominator, and you can just write that. You can write common denominator, and I actually also added the fractions. So I should call that out. I should say that I did that step. That's not so much of a reason as it is just what did I do? Sometimes the right side of the proof is just what did you do? This, though, is definitely going to be a reason. Sine squared plus cosine squared. Where have you seen that before? Well, everyone should say you've seen it, right? You've seen it equal 1. So take sine squared plus cosine squared, make it equal 1. Have a little fun when you do it, okay? Because that's the big purpose of this chapter. So we take sine squared plus cosine squared, we make it equal 1. Now you might feel like that you've seen a problem similar to this. If you've been paying attention, it is true. I did an example that was very similar to this because I'm trying to get you guys to realize how we can cancel the denominator. Remember I said not to distribute the denominator? That's because right now I'm going to cancel it with my numerator. You're allowed to do that because they're exactly the same. And I still end up with a 1. There's kind of an imaginary 1 that's still left up here. Not this 1 that canceled out, but there's a 1 up here. Thank goodness, because that gives me 1 over cosine. And remember, the reason these proofs are supposed to be a little easier, well, I shouldn't say easier, but the reason that we might like them better is because, remember, we already know what this equals. And that's exactly what 1 over cosine is. Now, I missed a couple reasons over here. We kind of got carried away. We got to go back and make sure we say what happened. Sine squared plus cosine squared equaling 1. Excuse me, that 1 right there. That was very important. That was Pythagorean. Make sure you say that. Make sure you say Pythagorean identity. Okay, just so you know, when I eventually grade your proofs, I'm definitely going to be looking for that word Pythagorean. If you accidentally miss, maybe like what happened here, we did a reciprocal. If you accidentally miss that, I'll probably give you a pass. But why am I having trouble spelling this all of a sudden? Reciprocal. Is that right? It just, something looks funny. Oh, okay. It's hard to explain. It only happens when you get up in the chalkboard that just sometimes a letter seems funny, and it is. I also canceled in here. And technically, I should get that divide or cancel as part of one of these 2 steps. We should really get that word in there.
Oh, will we ever have to do one of these where like the answer doesn't actually work?
It's a good question. Like if I give you, the left side and it really doesn't equal the right side, no, that would sort of be cruel and unusual punishment. Okay, because if I give you one that's false, then you're never going to make it work. Now, Chase, I will give you one like that when it's a graph. Remember how that was our last thing we did. Maybe if you type it into your calculator, I think that's fair. These are all true. You're trying to prove why. I appreciate that question. That's good. I said we were going to do 4, so are you ready? I think we have some space over here for one more. I'm going to give this one a little title of polynomials and factoring. There we go, factoring. Polynomials and factoring. And I guess what I'm trying to kind of argue here is that if you see something of this form, sine to the 4th plus cosine to the 4th equals 1 minus 2 cosine squared plus 2 cosine to the 4th. Now that can look a little intimidating, but we want to feel like that this is a polynomial. It's got the possibility to use some factoring. Okay, and again, it's a polynomial because it's got those exponents. We see that it kind of looks like a trinomial over here. So again, a couple different reasons why it's in this category. I'm sort of looking at this and actually pausing myself because I'm wondering what we can do. Sometimes kids will look at the right side and notice that the right side is made up of all cosines. Now, it does have the number 1 and it has some other numbers, but generally the right side is all cosines. The left side is sines and cosines. I'm not sure I've actually given this strategy yet, but when you have this scenario, you want to be smart and realize that you could change this sine to be a cosine. Now, how in the world do you change a sine to be a cosine? Well, you don't just erase it and change the spelling, but you realize that a sine, when it's written as a square. Now, you've not seen this before, so relax, but sometimes we have to see something new. I'm changing sine to the fourth. I'm interpreting sine to the fourth to be a square square. I'm interpreting it to be a sine square square. And the reason that I'm interpreting it to be a square square is because you can change a sine squared to be a cosine squared. You can change a sine squared to be a 1 minus cosine squared. Now, there's no doubt that that is a little trick. It's a little trick that we have not done yet. But what do you think? Let's back up a second. I like to show these two steps so that we can notice why in the world did we do this. I started with sines and cosines, but everything is supposed to come out to be cosines. So I can change sines, specifically sine squareds, to be 1 minus cosine squareds. So sine squared can turn into 1 minus cosine squared. Okay, I still have this exponent, and you'll notice I didn't do anything with this cosine to the fourth because really there's nothing wrong with it. It already looks like part of my answer. What was this? Once again, it was some exponents. But this is the Pythagorean identity. And again, that's big stuff. You want to make sure that you say Pythagorean identity. And we're almost there. If you're a little bit like, how are we going to finish this? You have to think about how to deal with 1 minus cosine squared squared. You have to think about how you're going to foil. How you're going to foil that quantity squared. Now, some students might be able to foil this in their head. And what I'm saying is maybe you could skip a step. But definitely the way that you do the outside square is by thinking of this as a FOIL problem. Okay, and then you're going to distribute 4 times. You're going to end up getting a 1, a minus 2 cosine squared, and a plus cosine to the 4th. So when I FOIL that, I get 3 terms. I get a 1, I end up with minus 2 cosine squareds, and then a positive cosine to the 4th. Don't lose track, I already had a cosine to the 4th from the beginning. And that's exactly what I need because now I have 2 of them. Now you have 2 of them, which is my final answer. But we can show that. So you add your cosine to the fourth to get 2 cosine to the fourth. And we should go back here and give a couple reasons. But really, the things that I did here was ultimately some algebra. I mean, I guess you could say we did the FOIL method again. And then the very last step was just to add those cosine to the fourth so we can keep it simple and you can just say add. Now listen, this is one of those topics where there's not going to be somebody out in the real world that's going to make money doing this. You know, kind of the old question, who's going to do this? Or when am I ever going to need to know this? Okay, we're kind of past that point. What this is critical thinking. And when you guys go out in the real world, you're going to have to think. I don't know if you're going to have to think like this exactly. In fact, you're probably not, right? But you are going to have to think. And that's some of what's going on here. It is challenging, but it also can be kind of rewarding. And it's definitely part of trigonometry, which, again, you guys signed up for. But I want to make this that it's doable for you. And the way that I do that, or have tried to do that, is giving you some examples. There's a homework helper. But the real deal is next week. Next week, you guys are going to be given what I call the proof party. And the proof party is going to be 8 of these plus 1 more. So you're going to have to prove 9 problems. Now, they're very doable. And you'll see I give a way that I kind of help you to do them. But that'll become one of the more memorable things that you guys will do this year, which is to work through that proof party on Monday and Tuesday. So as I sort of promised at the beginning of the period, I'll bring the proofs and the music. If you want to bring some other things, you can, or just come with a good attitude, and that's what will be in the middle of next week. Okay, look at the 2 problems for homework. They are doable. Okay, I tried to make them similar to what you've seen already. I really challenge you to try to be successful with at least one of them. And it's not uncommon for people to get both of them correct, but try to be successful with at least one of them as you try both of them. Okay.